So guys, in today's session we are going to see certain important molecules and compounds of your group 17 elements. So in order to begin our session, the first important molecule we are going to study of your group 17 element is your chlorine. Yes, of course the formula is Cl2. Yes, it's a molecule, two Cls are present, so therefore Cl2. The first important part, let us see that how one can prepare your chlorine in the laboratory. Yes, so first of all, the preparation in the laboratory of your chlorine is carried out by treating manganese dioxide. You can just see manganese dioxide in the presence of HCl. In the presence of HCl. Basically, this HCl is a concentrated HCl. So we are going to get manganese dichloride. Along with that one, of course, the main product which we require, the chlorine gas getting liberated, along with to water. In case if I want to balance this, of course, here comes your 4 HCl, 2 and 2. Chlorine is balanced, Mn is also balanced, oxygen is also balanced. So when laborated, basically by treating the manganese dichloride with that of your concentrated HCl, one can easily prepare your chlorine. There is also another method, basically by utilizing your table salt NaCl, same part manganese dioxide plus that of your concentrated H2SO4 is used over here. Concentrated H2SO4. So here we'll be getting as an MnCl2, of course NaHSO4, sodium bisulfate, plus water, plus that of the last part, chlorine gas getting liberated. So in order to balance this, you'll be getting as a 4 NaCl, you'll be getting as a 4 H2SO4, then comes your 4 NaCl, so 4 NaHSO4, of course 2 water. So if you just pay close notation over here, we know that whenever NaCl is treating with that of your H2SO4, of course end product barutte HCl form agutte. Ide reaction ne adre ಏನು ಮಾಡಿದೀವಿ ನಾವು reactions na change ಮಾಡಿದೀವಿ ಅಷ್ಟೇ, nothing much we had. ಯಾವಾಗಲೂ ಒಂದು ಸಾಲ್ಟ್ ಆಸಿಡ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಅಫ್ ಕೋರ್ಸ್ ಇಲ್ಲೇ ನಮಗೆ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ NaCl plus H2SO4 ನಿಮ್ಗೆ ಏನು ಕೊಡುತ್ತೆ, ಒಂದು ಆಸಿಡ್ ಕೊಟ್ಟೆ ಕೊಡುತ್ತೆ, that is you, of course HCl ಕೊಟ್ಟೆ ಕೊಡುತ್ತೆ. The reaction is same, but what happens when you just take it in another way has been shown over here. So in the first case you have directly treated your manganese dioxide with a 4 HCl, whereas in the second case we are making the manganese dioxide to be treated in the presence of your sodium chloride and concentrated H2SO4. So this was the first important method. There is also another method where you could prepare your chlorine in the laboratory by the action of HCl or by the treatment of HCl over potassium permanganate. That is your KMNO4 plus HCl. If you're just going to treat it, you'll be going to get as a KCl plus MnCl2 plus H2O plus that of your chlorine gas getting liberated. So your 2 KMNO4 in the presence of your 16 HCl. Somewhat you have to remember this stoichiometry. Okay, of course you'll be getting as a 2 KCl and that of your 2 MnCl2. Of course we require here 16 hydrogens here. However, 2 hydrogens are there, so 8 2s are 16. What about your oxygen? 4 2s are 8. Yes, 4 2s are 8. H2O or 8 oxygen. What about your chlorine? So here also you'll be getting as an 2 2s are 4, 5, 6. Okay, here we require 16. So here comes your 5Cl2. 5Cl2. So this is another method of the preparation of your chlorine in the laboratory by treating your potassium permanganate with that of your concentrated HCl. Is that clear? Coming to now the manufacture of your HCl in an industrial process. Okay, manufacturing of HCl in a large scale. So this was in a small scale in the laboratory we are preparing. But when it comes to the concept of how to prepare this HCl in a large scale, of course we know that investment should be less, profit should be more. Once again, what we can do in the first process we are going to study, it's a named process which is called as Deacon's process. Don't spell it as a beacon. Okay, B if it comes means it gives you a dish to eat. So don't give it B, it is D. Deacon's process. So basically in this process what you are going to do is you are going to oxidize your HCl gas. what they are doing in the Dickens process, ಇಲ್ಲಿ ನಾವು HCl gas ನ oxygen ಜೊತೆ treat ಮಾಡ್ತೀವಿ in the presence of that of your CuCl2 catalyst. It is CuCl2 catalyst. The reaction is in this way. Of course HCl ಉಂಟು, ಅದನ್ನ ನಾವು atmospheric oxygen ಇಂದ oxidize ಮಾಡ್ತಾ ಇದೀವಿ in the presence of CuCl2. So what you are going to get, of course we require is a chlorine gas, but along with that one you will be getting your water. So if you just balance this, 2 2s are 4, yeah, 4 HCl, and over here if I write as a 2 H2, oh, balance, yes, 2 Cl2 plus 2 water, 4 HCl and O2. So here the catalyst is very much important. So what is the oxidation state of the copper over here? If you take it as a X minus 2 is equals to 0, X is equals to plus 2, X is equals to plus 2. So this is basically a cupric chloride. What I am saying, you just mark my words, it is a cupric chloride, because cuprous ಅಂದಾಗ ಅದಕ್ಕೆ +1 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇರುತ್ತೆ. ಫೆರಸ್ ಅಂದಾಗ ಯಾವ ತರ ಅದಕ್ಕೆ ಕಡಿಮೆ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಯಾವಾಗ ಇರುತ್ತೆ ಆ ತರ ಬಂದಾಗ ನಾವು OUS ನ ಆಡ್ ಮಾಡ್ತೀವಿ. Fe+3 ನ IC, because +2 ಇಂದ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ +3 ವಾಸ್ ಗ್ರೇಟರ್. ಆದ್ರೆ ಕಾಪರ್ ಅಲ್ಲಿ ಬರೋದು +1 and +2. ಸೊ ಇಲ್ಲಿ +2 ಗ್ರೇಟರ್ ಆಗಿರುತ್ತೆ. ಸೊ therefore it is a cupric chloride. Okay, so when you're oxidizing your HCl gas in the presence of your cupric chloride catalyst, we will be getting our chlorine on a large scale. Okay, this is one industrial method by the name called as Dickens process. Coming to another process, a well-known process for us, which is your electrolytic process. Electrolytic process, that is carrying out your electrolysis. Basically by the electrolysis of your brine solution. What I am saying, electrolysis of brine solution. Most of you know what do you mean by brine solution. Yes, it is the concentrated NaCl solution. Concentrated NaCl solution. So when you are going to electrolyze your brine solution, basically you are going to get chlorine gas liberated. Chlorine gas liberated at the anode. Chlorine gas liberated at anode. This is also one of the important process, because they can ask you in 1 marks, during the electrolysis of brine solution, on which electrode, what is mark my question, on which electrode your chlorine gas is getting liberated? Basically it is your anode. Anodally chlorine gas is getting liberated. So these were the certain important part one has to know, how to prepare your chlorine both in the laboratory and that of your industrially. Coming with respect to their properties, basically these are properties of chlorine is somewhat, what you can say, many points are there. So basically we'll just see one by one. Okay, of course when I talk about its appearance and its odor, most of you are aware of it. We have done the salt analysis part in the lab, and of course we have detected the chlorine gas. Yes, basically it is a greenish yellow gas. Okay, it is a greenish yellow gas. No need to make you remind what was the odor. Yes, the pungent odor. So it was having a pungent suffocating odor. Alva, pungent suffocating odor. Coming with respect to its density wise, basically when you compare air and chlorine gas, okay, when you are going to compare the density of your air and the chlorine gas, do remember your chlorine gas is nearly 2 to 5 times heavier than air. Heavier than air. Air ಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ what you can say, chlorine gas in density ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಲ್ವಾ. ಅದೇ ರೀಸನ್ ಗೆ ನಾವು ಲ್ಯಾಬ್ ಅಲ್ಲಿ ಮಾಡತ್ತಿಗೆ ಅದು ಈಸಿಯಾಗಿ ಮೇಲ್ ಹೋಗ್ತಾ ಇರಲಿಲ್ಲ. ನಿಮ್ಮ ಸುತ್ತಮುತ್ತನೇ ಇರ್ತಿದ್ವಲ್ಲ, ನೀವು ಅಷ್ಟಕ್ಕೆ ನಾವೇನ್ ಹೇಳ್ತಾ ಇದ್ವಿ, ಲ್ಯಾಬ್ ಮಾಡತ್ತಿಗೆ ಫಸ್ಟ್ ನಾವು ಡಿಸ್ಕಾರ್ಡ್ ಮಾಡ್ತೀವಿ, ವಾಟರ್ ಬಿಡಿ ಅಂತೀವಿ. ಇಲ್ಲಾಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಗ್ಯಾಸ್ ನಮ್ಮ ಸುತ್ತಮುತ್ತನೇ ಹಾವಿಯಾಗಿ ಇರುತ್ತೆ, ಅದು ನಮ್ಗೆ ಸ್ಮೆಲ್ಲು ಜಾಸ್ತಿ ಬರುತ್ತೆ. ಬಿಕಾಸ್ ವೈ, ಆ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಇದ್ದಂಗೆ ಏನಾಗುತ್ತೆ, ಅದು ಕೆಳಗಡೆನೆ ಆ ಗ್ಯಾಸು ಓಡಾಡ್ತಾ ಇರುತ್ತೆ. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಗೋಯಿಂಗ್ ಅಪ್, what will happen, it will be remaining at the bottom itself, which will be much suffocating for us. Why is it so? Because you could just see that density of your chlorine gas is nearly 2 to 5 times heavier than air. Coming to certain important reactions, okay, because in the properties of chlorine we are going to see many much reactions, of course, which are very much important. First of all, we are going to see that how does your chlorine is going to react with the metals and the non-metals. Do remember, chlorine reacts with almost all the metals and non-metals. So whenever they are going to react with such metals and non-metals, they are going to form their respective chlorides. For example, if I am going to treat my aluminium with chlorine, it is going to give you as an aluminium trichloride, AlCl3. So AlCl3 means if I put here is a 2Al, yes, here comes your 3Cl2 and here comes your 2A. Not only in this case, even when you are going to treat your sodium with chlorine, yes, of course you know what it is going to form, yes, 2NaCl. So here comes your 2 part. Similarly, that of your iron with chlorine, yes, it is going to give you the ferric chloride, FeCl3. In case if I am going to balance 2, 3Cl2, 2Fe. So these were the certain important cases where we could see the reaction of the chlorine with the metals where they are forming their respective metal chlorides. Coming with respect to their non-metals, when you are going to treat with the phosphorus P4, in the presence of Cl2, it is going to give you as a phosphorus trichloride. Phosphorus trichloride. Yes, so 4 PCl3, 4 3s are 12, so 6 Cl2. Similarly, when you treat your sulfur with chlorine, Cl2, it is going to give you as a sulfuryl chloride. S2 Cl2, balance this, yes, 4 S2Cl2, so 4 2s are 8, so here comes your 4 Cl2. So in all the cases what we are observing is they are forming their respective chlorides. So when you was treating with the metals, it is forming a chlorides itself, whereas similarly when it is treated with the non-metals, they will be forming their respective chlorides. This is one important property of your chlorine. The next important property we are going to see how much affinity it is having with respect to your hydrogen. Basically, whenever we talk about the chlorine, do remember it is having a very high affinity towards the hydrogen. ಏನು ಹೇಳ್ತೀವಿ, ಕ್ಲೋರಿನಿಗೆ ಒಂದು ವೇಳೆ ಎಲ್ಲಾದ್ರೂ ಒಂದು ಹೈಡ್ರೋಜನ್ ಸೋರ್ಸ್ ಉಂಟು ಅಂದ್ರೆ ಅಲ್ಲಿಗೆ ಅದು ಫಸ್ಟ್ ಅಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ. Remarking my words, that is the reason we say that chlorine is having the high affinity towards the hydrogen. Chlorine has high affinity towards hydrogen. Basically, it reacts with that hydrogen to form one important product, that is your HCl. Okay, ಯಾವಾಗಲೇ ಅಲ್ಲಿ ಕ್ಲೋರಿನಿಗೆ ಯಾವುದೇ ಒಂದು ಪ್ರೋಟಾನ್ ಅಥವಾ ನಿಮ್ಮ ಹೈಡ್ರೋಜನ್ ಸೋರ್ಸ್ ಸಿಕ್ಕರೆ ಅದು ಫಾರ್ಮ್ ಆಗದೆ ಅಲ್ಲಿ HCl. The important reaction we can just see direct like first ನೋಡೋಣ. When you having your hydrogen in the presence of chlorine, of course you are going to get as that of your 2HCl. Similarly, that of your hydrogen sulfide with chlorine, you are going to get as a HCl plus that of your sulfur. When you balance this, H2, yes, 2Cl, so 2HCl. Similarly, when you're treating that of your CnH2n plus 2, CnH2n, yeah, C10H16 with that of your Cl2, you're going to get as that of your HCl plus that of your 10 carbon. So in case you have to balance this, you are going to get as a 16HCl and over here as an 8Cl2. So in all these cases, you could just see that whenever chlorine has a tendency to react with any source of hydrogen, it always forms an important part, that is your hydrogen chloride. So these are the certain important reactions indicating the high affinity of chlorine towards your hydrogen. Okay, the next part I am going to categorize certain important properties. Basically, what happens when your chlorine reacts with ammonia. Very much important reaction, guys. Please make a note of it, because in these reactions we are going to categorize and see that what happens when you treat chlorine with excess of ammonia and what happens when you treat ammonia with excess of chlorine. Okay, first ನಾವು ಅಮೋನಿಯಾ ಎಕ್ಸಿಸ್ ತಗೊಂಡು ಏನ್ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ ಅಂತ ನೋಡ್ತೀವಿ. ಅದೇ ರೀತಿ ನೆಕ್ಸ್ಟ್ ಲೈನ್ ಮಾಡ್ತೀವಿ, ಕ್ಲೋರಿನ್ ನ ಎಕ್ಸಿಸ್ ಆಗಿ ತಗೊಂಡು ಅಮೋನಿಯಾದ ಟ್ರೀಟ್ ಮಾಡಿದಾಗ ಏನ್ ಬರುತ್ತೆ ಅಂತ ನೋಡ್ತೀವಿ. ಡೂ ರಿಮೆಂಬರ್, ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ ರಿಯಾಕ್ಷನ್ಸ್, ಈ ತರ ರಿಯಾಕ್ಷನ್ಸ್ ತುಂಬಾನೇ ಮುಖ್ಯ. ಓಕೆ, ಯಾಕೆ ಅಂದ್ರೆ ಬೇಸಿಕಲಿ ನಮ್ಮ ಫೋಕಸ್ ಈ ತರ ರಿಯಾಕ್ಷನ್ಸ್ ಮೇಲೆನೆ ಇರುತ್ತೆ. ಒಂದು ಎಕ್ಸೆಸ್, ಇನ್ನೊಂದು ನೀವು ಲಿಮಿಟೆಡ್ ಆಗಿ ತಗೊಂಡಿರ್ತೀರಾ, ನೆಕ್ಸ್ಟ್ ಅಲ್ಲಿ ಅದನ್ನ ಎಕ್ಸೆಸ್ ಮಾಡ್ತೀರಾ, ಏನ್ ಲಿಮಿಟೆಡ್ ಆಗಿ ತಗೊಂಡಿರ್ತೀರಾ ಅದನ್ನ ಎಕ್ಸೆಸ್ ಮಾಡಿರ್ತೀರಾ, ಏನ್ ಎಕ್ಸೆಸ್ ಆಗಿ ತಗೊಂಡಿರ್ತೀರಾ ಅದನ್ನ ಲಿಮಿಟೆಡ್ ಮಾಡ್ತೀರಾ. ಸೊ ಏನಲ್ಲಿ ಚೇಂಜಸ್ ಆಫ್ ಪ್ರೊಡಕ್ಟ್ಸ್ ಬರುತ್ತೆ ಅನ್ನೋದೇ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ ದಟ್ what happens when chlorine is treated with that of your excess of ammonia. Okay, excess of ammonia. So this is your excess of ammonia. Do remember, so when you're treating your chlorine with excess of ammonia, basically you're going to get as that of your ammonium chloride with the liberation of your nitrogen gas. Basically, when you're treating your chlorine with that of your ammonia, you're going to get as an ammonium chloride with the liberation of your nitrogen gas. When you balance the reaction, basically, yes, here is your 8 ammonia, because if you are taking in an excess, it is your 8 ammonia. So in case if I am to make it as a 8 here, I am having the 2 nitrogens. So 4 over here, 8 3s are 24. Yes, so 6 NH4Cl, 6 NH4Cl plus N2. So here comes your 3Cl2, 3Cl2. So when you're going to treat your chlorine with excess of ammonia, do remember you're going to get as an ammonium chloride with the liberation of nitrogen gas. Very much important, the stoichiometry. Okay, one has to remember the stoichiometry. So the next we are going to see that what happens when you're going to treat ammonia with excess of chlorine. Okay, so in case now if I am going to treat ammonia with excess of chlorine, please make a note what is the change of the products you're going to get. Here we are going to get as a nitrogen trichloride, nitrogen trichloride along with HCl, nitrogen trichloride along with HCl. Basically here what I have taken, excess of chlorine. So this nitrogen trichloride over here acts as an explosive. Okay, the nitrogen trichloride, whatever it has been formed over here, it is acting as an explosive. Can you make a note over here? So when we are talking about the excess of ammonia, we got as an ammonium chloride with the liberation of the nitrogen gas. But when the same reaction is same, just we have changed the concentration and we have taken the chlorine in excess, we are going to get an explosive, which is your nitrogen trichloride. So in order to balance this, yes, if I put here as 2 NCl3, so 3Cl2. What about your 3 2s are 6, no 7? It will not get balanced, alba. Okay, 3 2s are 6. If I put over here as a 3 HCl, yes, 3 HCl, so now H is balanced, okay, N is also balanced. So NH3 plus 3Cl2 gives you as a NCl3 plus that of your 3 HCl. Are you able to see? So this is a certain important part one has to note whenever you're reading your inorganic reactions. The next part we are going to see that what happens when your chlorine, okay, what happens when your chlorine reacts with hot and concentrated alkali, hot and concentrated alkali, similarly cold and dilute alkali, cold and dilute alkali, one of the most important reaction once again. So do remember, when you're going to treat your chlorine with that of your cold and dilute NaOH, basically we are going to get a mixture of chloride salt and that of your hypochlorite, NaOCl plus that of your H2O, NaOCl plus H2O. So here comes your 2 NaOH. Everything else is balanced, NaClCl, 2 oxygens, yes, balance. So basically this is called as a sodium hypochlorite. Okay, this is called as what? Sodium hypochlorite. So when you are going to treat with that of the chlorine with a cold and dilute, this is in the case of the cold and dilute alkali. Alkali means base alva, illi na base yav tagondidini, NaOH na use madidini. Similarly when you treat, okay, similarly when I treat hot and concentrated alkali, hot and concentrated alkali, basically here we are going to treat your NaOH plus that of your Cl2 to give you as an NaCl plus here you are going to just see NaClO3, which is your chlorate. Okay, in chlorate, okay, plus that of your water, H2O. So NaOH plus Cl2. This is the case when you are treating with a hot and concentrated alkali. Remember, when you were treating with the cold and dilute alkali, we have got as what? Hypochlorite. Whereas when you are treating with respect to the hot and concentrated alkali, you are going to get as what? Chlorate. So basically it is your sodium chlorate, sodium chlorate. Okay. So in order to balance this, you just have a look. Okay, 2 Na we are requiring. Okay. So before going to that one, we'll go with my Cl. Here we are having the 2 Cls. What about your oxygen? Here 3 plus 1, 4 we are having. So let's begin with 3Cl2. 3Cl2. So in that case, if I want to add my 3Cl2, so I'm having my 3 2s are 6. 3 2s are 6. So here I could just add my 5 NaCl. 5 NaCl. So 5 plus 1, 6. So 6 NaOH. 6 NaOH and that of your 3 water. 3 water. So this is actually the reaction. Whenever you are treating your sodium hydroxide with what you can say hot and a concentrated alkali, we are going to get as a, mainly you are going to get as a chlorate. But when you're treating your chlorine with that of your cold and dilute NaOH, you are going to get as that of your respective hypochlorite. Is that clear? This was a certain important reaction. Coming to the next part or the next important property and next important reaction is reaction with slaked lime. Reaction with slaked lime. Okay, what happens when you're going to treat your chlorine with slaked lime? Basically, slaked lime means, of course, you know, it is calcium hydroxide. Okay, so when I'm going to treat my calcium hydroxide with chlorine, you are going to get as a calcium hypochlorite, that is COCl twice. You just remember, very much important formula it is, okay, because it is acting as a bleaching powder, a very much important component of your bleaching powder. Yavagli now bleaching powder na yen use martivala, the main thing which is main thing, okay, main thing is the composition unto, the main thing which is important is that of your CaOCl twice. Certain people write it as, when you're writing, you make a mistake as CaOCl2. No, it is wrong. You just see what is the difference. The 2 is applicable both for your oxygen as well as that of your chlorine. So this is the actually the formula, not one, this is not. Okay, so this is only possible when you're treating your chlorine with slaked lime. So whenever you're going to treat your chlorine with a dry slaked lime, you are going to get as a bleaching powder. Along with that one, we are going to get a CaCl2 plus 2 water. Okay, actually, okay, this is the important part. But whenever we are asked to write the composition of the bleaching powder, we write the overall thing. Okay, the main overall main composition is this part, but overall the composition of the bleaching powder in martivi andre overall elladnu baritive ನಾವು CaOCl twice. Okay, ಇದು ಬರ್ದ್ವಾ dot ಈ ಪ್ಲಸ್ ನ ತೆಗಿರಿ ಅಷ್ಟೇ, CaCl2, okay, dot, then write this part, your slaked lime, CaOH twice, dot, and write then this part, 2H2O. So this is actually the main overall composition of your bleaching powder. ಏನು ಮಾಡಿದ್ರಿ, ಫಸ್ಟ್ ನೀವು calcium hypochlorite ಬರ್ದ್ರಿ, then you wrote as a calcium chloride, then coming with respect to the dry slaked lime, finally your water. Only chlorine has been missed out. So if you remember this reaction, of course you can write the overall composition of your bleaching powder. Coming with respect to now reaction with hydrocarbons. Reaction with hydrocarbons. So basically, whenever you're going to talk about the reaction of hydrocarbons with chlorine, we are going to see the two important types over here. That is, what happens when your chlorine reacts with a saturated hydrocarbon. Similarly, what happens when your chlorine reacts with an unsaturated hydrocarbon. Of course, 1 marker question and also important for your competitive exam. Why I am saying so? So whenever you talk about your saturated hydrocarbons reacting with the chlorine, first of all, we'll understand what type of a reaction is going to take over here. Basically, it will be a substitution reaction. It will be a substitution reaction. For example, if I use CH4 in the presence of that of your chlorine and in the presence of a UV light, you will be going to get as a CH3Cl plus that of your HCl. How, sir, it is a substitution reaction? You could just note that carbon was having 4 hydrogens, but here it has been substituted 1 hydrogen with respect to 1 chlorine. ಏನಾಗಿದೆ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಗಿದೆ, 1 ಹೈಡ್ರೋಜನ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಕ್ಲೋರಿನ್ ಬಂದಲ್ಲಿ ಕೂತಿದೆ. ಸೊ ಯಾವಾಗ ನಿಮ್ಮ ಕ್ಲೋರಿನ್ ಸ್ಯಾಚುರೇಟೆಡ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೋ ಅವೆಲ್ಲವೂ ಏನ್ ಕೊಡುತ್ತೆ, ನಿಮಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್ ಕೊಡುತ್ತೆ. Can anybody guess what does it can give you with unsaturated hydrocarbons? Yes, just guess till I write it. Unsaturated hydrocarbons. Yeah, basically whenever your chlorine is going to react with the unsaturated hydrocarbons, do remember it is going to give you an addition reaction. Okay, it will be an addition reaction. So what is the main difference we're going to see over here? So for example, if I use as a C2H4, okay, C2H4 hangare yav ತರ ಇರ್ತದು, CH2 double bond CH2 alva, C2H4. So basically when you are going to treat this one with a chlorine at a room temperature nearly 27 degrees Celsius, yes, we are going to get as what? For example, if I am going to write C2H4Cl2, can you see an addition product? ಇಲ್ಲಿ ಏನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಗಿಲ್ಲ, C2 ಹಾಗೆ ಉಂಟು, H4 ಹಾಗೆ ಉಂಟು, ಡೈರೆಕ್ಟ್ ಆಗಿ Cl2 ಹೋಗಿ ಅಟ್ಯಾಚ್ ಆಗಿದೆ. ಹೆಂಗೆ ಅಟ್ಯಾಚ್ ಆಗಿರುತ್ತೆ, ಈ ಬಾಂಡ್ ನ ಇದು ಮಾಡಿಕೊಂಡು it will coming as a CH2Cl single bond CH2Cl. ಸೊ ಓವರ್ ಆಲ್ ಇದನ್ನ ನಾವು ಏನಂತ ಬರ್ಕೊಂಡಿವಿ C2H4Cl2. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ ಯಾಕೆ ಇದನ್ನ ಹೇಳ್ತಿದ್ದೀನಿ ಅಂದ್ರೆ ದೇ ಕ್ಯಾನ್ ಆಸ್ಕ್ ಯು ಇನ್ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಾರೆ ಒಂದು ರಿಯಾಕ್ಷನ್ ನ ಕೊಟ್ಟು ಕ್ಲೋರಿನ್ ಜೊತೆ ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ ಕೊಟ್ಟು ವಾಟ್ ಟೈಪ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಇಸ್ ಇಟ್, ಅಡಿಷನ್, ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್, ಎಲಿಮಿನೇಷನ್ ಅಂತ ಕೊಟ್ಟು 4-5 ಆಪ್ಷನ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಸೊ ರಿಮೆಂಬರ್, whenever chlorine is reacting with the saturated hydrocarbons, it is your substitution reaction, whereas whenever your chlorine is reacting with the unsaturated hydrocarbon, it is your addition reaction and it gives you an addition product, whereas with the saturated hydrocarbon it gives you the substituted product. Okay, coming to the another part of the property, yes, it is somewhat lengthy but also very much important, guys. Okay, because we are seeing many reactions over here and also one of the interesting reactions. So remember, your chlorine, whatever is there, okay, your chlorine, basically it has a better oxidizing agent. Okay, it is a good oxidizing agent. But the interesting fact is, what you know, chlorine ಹೆಂಗೆ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ಆಕ್ಟ್ ಆಗ್ತಾ ಉಂಟು ಒಂದು ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಪಾರ್ಟ್. ಸೊ ಯಾವಾಗ ಈ ಕ್ಲೋರಿನ್, ಓಕೆ, ಇಫ್ ಇಟ್ ಇಸ್ ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಫಾರ್ ಅ ಲಾಂಗ್ ಟೈಮ್, ಓಕೆ, ಏನ್ ಹೇಳ್ತಿದ್ದೀನಿ, ವೆನೆವರ್ ಯು ಕೀಪ್ ದಿ ಕ್ಲೋರಿನ್ ಆಸ್ ಇಟ್ ಇಸ್, ಓಕೆ, ಕ್ಲೋರಿನ್ ನಾವು ಆಸ್ ಇಟ್ ಇಸ್ ವಿತೌಟ್ ಎನಿ ಶೇಕಿಂಗ್ ಗೀಕಿಂಗ್ ಏನು ಮಾಡ್ದೇನೆ ಹಾಗೆ ಇಟ್ಬಿಟ್ರೆ ಏನ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಬೇಸಿಕಲಿ ಇಟ್ ಲೂಸಸ್ ಇಟ್ಸ್ ಯೆಲ್ಲೋ ಕಲರ್. ಅದು ಮೇನ್ಲಿ ಆಗಿ ಗ್ರೀನಿಶ್ ಯೆಲ್ಲೋ ಕಲರ್ ಇರುತ್ತೆ, ಆ ಯೆಲ್ಲೋ ಕಲರ್ ಹೋಗುತ್ತಾ. ಯೆಲ್ಲೋ ಕಲರ್ ಯಾಕೆ ಹೋಗ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಬೇಸಿಕಲಿ ಆ ಕ್ಲೋರಿನ್ ಏನಿರುತ್ತಲ್ಲ ಆ ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಪ್ರೊಸೆಸ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಇಟ್ ಇಸ್ ಗೆಟಿಂಗ್ ಕನ್ವರ್ಟೆಡ್ ಟು HCl ಅಂಡ್ HOCl. ಏನ್ ಹೇಳುತ್ತೆ, HCl ಅಂಡ್ HOCl. ಬೇಸಿಕಲಿ HOCl ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಹೈಪೋಕ್ಲೋರಸ್ ಆಸಿಡ್. ಹೈಪೋಕ್ಲೋರಸ್ ಆಸಿಡ್, ಓಕೆ. ಈ ಹೈಪೋಕ್ಲೋರಸ್ ಆಸಿಡ್ is actually the culprit which makes the chlorine to act as an oxidizing agent. ಈ HOCl ಹತ್ರ ಏನುಂಟಲ್ಲ, ಬೇಸಿಕಲಿ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಸಿ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಒನ್ ಆಕ್ಸಿಜನ್. ಸೊ ಇದು ಆ ನೇಸೆಂಟ್ ಆಕ್ಸಿಜನ್, ಇದು ವೆರಿ ರಿಯಾಕ್ಟಿವ್ ಆಕ್ಸಿಜನ್. ಓಕೆ, ನೇಸೆಂಟ್ ಅಂದ್ರೆ ವೆರಿ ರಿಯಾಕ್ಟಿವ್. ಓಕೆ, ಒಂದೇ ನೇಸೆಂಟ್ ಆಕ್ಸಿಜನ್, ಯಾವತ್ತೇ ನಾವು ನೇಸೆಂಟ್ ಬರೀ ಹಿಂಗ್ ಬರೀತೀವಿ, ಇಟ್ಸ್ ಅ ವೆರಿ ರಿಯಾಕ್ಟಿವ್ ಆಕ್ಸಿಜನ್ ನ ಕೊಡುತ್ತೆ. ಈ HOCl ಏನ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಉಂಟು ಕ್ಲೋರಿನ್ ಇಂದ, ದಿಸ್ ಇಸ್ ದಿ ಆಕ್ಚುಲಿ ದಿ ಮೇನ್ ಕಲ್ಪ್ರಿಟ್ ವಿಚ್ ಇಸ್ ಮೇಕಿಂಗ್ ದಿ ಕ್ಲೋರಿನ್ ಟು ಆಕ್ಟ್ ಆಸ್ ಅ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್. And also it is also responsible for the bleaching properties of chlorine. Of course many of the girls will know it. Chlorine ನಾವು ಬ್ಲೀಚಿಂಗ್ ಏಜೆಂಟ್ ಹಂಗೇನು ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಲ್ವಾ. ಸೊ ಬೇಸಿಕಲಿ ಆ ಒಂದು ಪ್ರಾಪರ್ಟಿ ಇಲ್ಲಿಂದ ಬರ್ತಾ ಉಂಟು, the bleaching property that also is coming from this nascent oxygen. First of all we will see where is this working as an oxidizing agent. So basically when we treat your iron sulfate FeSO4 in the presence of H2SO4, yes, and in the presence of a chlorine, it is going to get you as a Fe2SO4 thrice plus that of your HCl. Illi sir il oxidizing agent aitu. So you can just see here Fe was in the +2, whereas here Fe is in the +3 state. Oxidation agide alva, loss of electrons, where your ferrous has been oxidized to ferric. Coming with respect to the sodium sulfite, Na2SO thrice. Okay, this is in the presence of Cl2 and that of your water. It is going to give you as an Na2SO4 plus that of your HCl. So sulfite, it is sulfate again. If you just calculate the oxidation state of the sulfur over here, what you'll be getting here, you're going to get as a +4. 3 2s are 6, 6 minus 2 andre +4. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ 4 2s are 8, 8 minus 2 andre +6. So +4 in the +6 ಗೆ ಹೋಗಿದೆ. So 2 electrons has been lost. Similar is the case when you're going to treat your sulfur dioxide, that is your SO2 in the presence of water. Do remember, in the presence of water and that of your chlorine, you're going to get as your sulfuric acid plus that of your HCl. Yes, similar is the case by converting your iodine to iodate. Here also the reaction takes place in the presence of water and the chlorine to give as that of your HiO3 plus that of your HCl. So in all these cases where you could just notify that your chlorine is acting as one of the good oxidizing agent. But the important fact one has to know that chlorine itself is not acting as an oxidizing agent. Whatever the chlorine is there, due to the standing, our reaction ಸ್ವಲ್ಪ wait ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಆ chlorine ಯಾವ್ದಕ್ಕೆ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ, HCl and HOCl, that is your hypochlorous acid ಗೆ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಈ hypochlorous acid is actually the responsible and main culprit for the oxidizing properties of your chlorine. And here are certain examples. Of course, many times we have seen certain experiments whenever we spray chlorine for the colored clothes. ಅಲ್ವಾ, ಯಾವುದೇ ಒಂದು ಕ್ಲೋರಿನ್ ಈಗ ಕಲರ್ಡ್ ಕ್ಲೋತ್ಸ್ ಮೇಲೆ ಬಿತ್ತು ಅಂದ್ಕೂಡ ಏರಿಯಾ ಏನಾಗುತ್ತೆ, ಬ್ಲೀಚ್ ಆಗುತ್ತೆ. ಬ್ಲೀಚ್ ಅಂದ್ರೆ ಏನು, ವೈಟ್ ಆಗ್ಬಿಡುತ್ತೆ. ವಾಟ್ ಇಸ್ ದ ರೀಸನ್ ಫಾರ್ ದ್ಯಾಟ್? ಅದೇ ರೀಸನಿಂಗ್ ನಾವು ಹೇಳೋದು ಕ್ಲೋರಿನ್ ಇಸ್ ಆಕ್ಟ್ಸ್ ಆಸ್ ಒನ್ ಆಫ್ ದಿ ಪವರ್ಫುಲ್ ಬ್ಲೀಚಿಂಗ್ ಏಜೆಂಟ್. ಯಾಕೆ ಅದು ಹಂಗೆ ಆಕ್ಷನ್ ಯಾವ ತರ ಆಗ್ತಾ ಉಂಟು? ಬೇಸಿಕಲಿ ಇಟ್ ಇಸ್ ಡ್ಯೂ ಟು ದಿಯರ್ ಆಕ್ಸಿಡೇಷನ್. ಸೊ ಯಾವಾಗ ಕ್ಲೋರಿನ್ ಕಮ್ಸ್ ಇನ್ ದಿ ಕಾಂಟ್ಯಾಕ್ಟ್ ವಿತ್ ದಿ ವಾಟರ್, it will be forming as a HCl plus oxygen, a nascent oxygen. So when it comes in the contact, ಯಾವುದೇ ಒಂದು ಬಟ್ಟೆ ಮೇಲೆ colored substance is, of course it is also a chemical. So ಆ colored substance ಮೇಲೆ ಏನಾಗುತ್ತೆ, ಈ ಆಕ್ಸಿಜನ್ ಬಂದು ಕೂತಾಗ ಆ colored substance ಏನಾಗುತ್ತೆ, colorless substance ಆಗಿ ಆಕ್ಟ್ ಆಗುತ್ತೆ. This is actually the bleaching action of your chlorine. ಯಾಕೆ ಆ ವೈಟ್ ಆಗುತ್ತೆ ಬಟ್ಟೆ ಅಂದ್ರೆ, this is the actual reaction. Chlorine, when it reacts with the water, is going to give as a HCl plus oxygen. ನಾವು ಅದನ್ನು ಸ್ಪ್ರೇ ಮಾಡ್ತೀವಲ್ಲ, ಆ ಕ್ಲೋರಿನ್ ಏನ್ ಮಾಡಿದೀವಿ ಹಾಗಾದ್ರೆ ನಾವು ವಾಟರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಮಾಡಿದೀವಿ. ಸೊ ಆ ಕ್ಯಾನ್ ಒಳಗೆ ಏನಿರುತ್ತೆ ಈಗ HCl ಮತ್ತೆ ನೇಸೆಂಟ್ ಆಕ್ಸಿಜನ್ ಇರುತ್ತೆ. ಸೊ ಆ ನೇಸೆಂಟ್ ಆಕ್ಸಿಜನ್ ಬಟ್ಟೆ ಮೇಲೆ ಸ್ಪ್ರೇ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಬಟ್ಟೆ ಮೇಲೆ ಒಂದು ಕಲರ್ ಇರುತ್ತೆ. ಸೊ ಆ ಕಲರ್ ಏನ್ ಮಾಡುತ್ತೆ, ಇಟ್ ಕಮ್ಸ್ ಇನ್ ದಿ ಕಾಂಟ್ಯಾಕ್ಟ್ ವಿತ್ ದಿ ಆಕ್ಸಿಜನ್, ನೇಸೆಂಟ್ ಆಕ್ಸಿಜನ್, ವೆರಿ ಮಚ್ ಆಕ್ಟಿವ್. ಸೊ ಗಿವಿಂಗ್ ಯು ಆನ್ ಕಲರ್ಲೆಸ್ ಸಬ್ಸ್ಟೆನ್ಸ್, ವೈಟ್ ಕಲರ್ ಬ್ಲೀಚ್ ಆಗ್ಬಿಡುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? ಸೊ ದಿಸ್ ಇಸ್ ಆಕ್ಚುಲಿ ದ ರಿಯಾಕ್ಷನ್ ವಿಚ್ ಇಸ್ ಟೇಕಿಂಗ್ ಪ್ಲೇಸ್ on the surface of your clothes. So that is the reason we say that your chlorine is acting as a powerful bleaching agent, and whatever the bleaching action we are going to see of your chlorine is mainly due to the oxidation process. Mainly due to the oxidation process. So coming now with respect to its uses. Of course, they are used in the textile industry and also in the paper industry for bleaching process. Alva bleaching process basically they will be used. Similarly, very much important use in the extraction of gold and platinum. In the extraction of gold and platinum, you're going to see why, how come it is going to help in these cases. When we're going to see another important compound, that is your HCl. Okay. Similarly, another important use in the manufacture of very much dyes, drugs, and organic compounds. Basically, this chlorine is one of the key role played over there. Okay, these are the certain important uses, but I would like to say once again, we have to focus more on the reactions part. What happens when chlorine reacts with the slaked lime? What happens when chlorine reacts with the metals, with non-metals, with the dry slaked lime? Okay, what is the bleaching action of your chlorine? What is the composition of your bleaching powder? How can you manufacture the bleaching powder? All these are the certain important cases which could be asked in either ways. Okay, so most important thing is you have to notify on the reactions. Yeah, very much important is how does your chlorine reacts with the hot and concentrated alkali, dilute and cold alkali? What happens when chlorine reacts with the excess of ammonia? What type of a product you are going to get? What happens when you are going to react with the excess of chlorine? What is the type of the product you are going to get? So these are the certain important reactions so far we have studied with respect to the chlorine. So the next important part we are going to study is with respect to your hydrogen chloride. Okay, hydrogen chloride. Okay. So guys, the first part we're going to see with respect to the hydrogen chloride is about their preparation. How you're going to prepare it. So basically in the lab you are going to prepare your hydrogen chloride by treating your sodium chloride with concentrated H2SO4. At nearly the temperature range is 420 Kelvin. Yeah, very good temperature, 420. I hope so you can remember it. Sodium bisulfate plus that of your HCl. Alva. So you could just see that how HCl has been formed. There is also another method by treating your sodium bisulfate with directly with that of your NaCl. Temperature range you have to maintain as nearly 823 Kelvin. Here also you will be getting as a sodium sulfate, but along with that one we require the important product, that is your HCl. So these are the two important methods. One can easily prepare your HCl in the laboratory. One is by treating your NaCl with concentrated HCl. Another is by treating your sodium bisulfate. Mark my words, sodium bisulfate with NaCl at 823 Kelvin temperature. So whatever the HCl you're going to obtain over here, they will be somewhat moist. Okay, they will be having the water droplets. So we are going to dry it by passing through the concentrated H2SO4. Yake concentrated H2SO4? Yes, because concentrated H2SO4 acts as a dehydrating agent. Allow water na adu easy agi remove madutte. Okay, now this was certainly important. Here you are not having any industrial application, so directly we can go. Sorry, industrial preparation illa direct agi now properties ಗೆ jump padiyana. So let us deal with the properties of your hydrochloric acid. So basically whenever again and again when I am saying as a HCl, I am adding the word as an acid. Okay, HCl acid, hydrochloric acid. Why I am using this word? How to state? Of course so we all know HCl is an acid, but how first initially how was it known? Of course, whenever we talk about an acid, whenever it's going to dissolve in water, of course it has to give what? Proton. Similar is the case with your HCl. So when HCl is treated with water, it also ionizes to give you a hydronium ion plus Cl minus. So once you're getting this hydronium ion, of course you get to know that the given compound is an acid. HCl ಇದ್ದು ವಾಟರ್ ಜೊತೆ ವಾಟರ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಆ HCl ಇದ್ದು H3O ಪ್ಲಸ್ ಗೆ ಅಯೋನೈಸ್ ಆಗಿ ನಿಮಗೆ ನಿಮ್ಮ Cl ಮೈನಸ್ ಸಿಗುತ್ತೆ. ಸೊ ಈ H3O ಪ್ಲಸ್ ನಮ್ಗೆ ಏನ್ ಇಂಡಿಕೇಟ್ ಮಾಡುತ್ತೆ, ದ ಗಿವನ್ ಮಾಲಿಕ್ಯೂಲ್ ದಟ್ ಇಸ್ ಯೋರ್ HCl is acting as an acid. The next important part we are going to see that what happens when your HCl reacts with the NH3. Okay, so when you're trying to treat your HCl with that of your ammonia, basically you are going to get a dense white fumes of your ammonium chloride. So ammonium chloride sigutte, which will be appearance ilinda barutte nimage dense white fumes. Of course it's a neutralization reaction, HCl reacting with NH3, but both are in the gaseous part. ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಈ ಬರೋದು ಕೂಡ ನಿಮ್ಗೆ ಏನಾಗಿರುತ್ತೆ, ಗ್ಯಾಸ್ ಆಗಿ ಇರುತ್ತೆ, which will be having the appearance of your dense white fumes. Okay, but the important and the most which I was liking the most important reaction was a concept called as your aqua regia. Okay, ಏನಿದು aqua regia ಅಂದ್ರೆ, basically aqua regia is the mixture. Okay, what it is, it's a mixture of concentrated HCl and concentrated HNO3. Not only that much, ಎಷ್ಟು ತಗೋಬೇಕು ಅಂತಾನೋ ಅದು ನಮ್ಗೆ ಹೇಳುತ್ತೆ. Basically it's a mixture of, remember, very much important, 3 parts. Okay, mixture of 3 parts concentrated HCl and 1 part concentrated HNO3. ಸೊ ಈ ಒಂದು ಮಿಕ್ಸ್ಚರ್ ನಾವೇನಂತ ಹೇಳೋದು, ಅಕ್ವಾ ರೀಜಿಯಾ ಅಂತ ಹೇಳೋದು. 3 ಪಟ್ಟು ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ HCl ಇದ್ರೆ 1 ಪಟ್ಟು ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ HNO3 ಇದ್ದು ಅದನ್ನ ನಾವು ಮಿಕ್ಸ್ ಮಾಡಿದ್ರೆ ಆ ಒಂದು ಮಿಕ್ಸ್ಚರ್ಗೆ ನಾವೇನಂತ ಹೇಳೋದು, ಅಕ್ವಾ ರೀಜಿಯಾ. Some fellows write it as a mixture of concentrated HCl and HNO3. Of course, it will be a wrong answer because we must be taken care of its stoichiometry. 3 parts of a concentrated HCl and 1 part of a concentrated HNO3. Their mixture is called as that of your aqua regia. Why my focus is over here is because by utilizing this aqua regia, one can easily extract the noble metals. ಯಾವುದು noble metals ಅಂದ್ರೆ, ಇಲ್ಲಿವರೆಗೆ ನಾವು ನೋಡಿದ್ವಿ ಗೋಲ್ಡ್ ಅಂಡ್ ಪ್ಲಾಟಿನಮ್. ಎಲ್ಲೇ ನಾವು ಓದಿದ್ರು ಎಲ್ಲಾ ಕಡೆ ನಾವೇನ್ ನೋಡ್ತಾ ಬಂದ್ವಿ, ಆ ಒಂದು ಯಾವುದೇ ಒಂದು ಎಲಿಮೆಂಟ್ ಆಗ್ಲಿ ಈ ಮೆಟಲ್ಸ್ ಇದೆ ಅಷ್ಟು ಸುಲಭವಾಗಿ ರಿಯಾಕ್ಟ್ ಆಗಲ್ಲ. ಬಟ್ ದಟ್ಸ್ ನಾಟ್ ದಿ ಕೇಸ್ ಆಫ್ ಯೋರ್ aqua regia. ಈ ಒಂದು aqua regia ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಏನ್ ಹೆಲ್ಪ್ಫುಲ್ ಅಂದ್ರೆ, ವಾಟ್ ಎವರ್ ದಿ ಓರ್ಸ್ ಆಫ್ ದಿ ಗೋಲ್ಡ್ ಅಂಡ್ ಪ್ಲಾಟಿನಮ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್, ಅಲ್ಲಿಂದ ನಾವು ಈಸಿಯಾಗಿ ಗೋಲ್ಡ್ ಮತ್ತೆ ಪ್ಲಾಟಿನಮ್ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಐ ಆಮ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ದಿ ಗೋಲ್ಡ್, ಇಲ್ಲಿ ನಾನು ಗೋಲ್ಡ್ ಬರೀತಿದೆ, ಇಟ್ಸ್ ನಾಟ್ ದಿ ಪ್ಯೂರೆಸ್ಟ್ ಗೋಲ್ಡ್. ಓಕೆ, ಇಟ್ ಇಸ್ ಅನ್ ಗೋಲ್ಡ್ ಓರ್. So first of all, we are going to treat this in the presence of an aqua regia. So I am writing my aqua regia in this ionic equation baritini, NO3 plus and Cl minus. So here you are going to get as an, yes, auric chloride, AuCl4 minus. Of course, we have written this reaction even in our isolation of element, general principles and isolation of elements in the extraction of gold from its ore. Coming with respect to that one, you will be having your nitric oxide plus water. So if you are going to balance this, you are going to get a 4H plus, NO3 minus, okay, as it is, and a 4Cl minus. So you are going to get AuCl4 minus, NO. What about your water? Is it balanced? 4H plus, so you are going to get as a 2 water. So basically this aqua regia has the capacity to dissolve your noble metals. Noble metals means your gold and platinum. Similar is the case with respect to the platinum. Here we are going to treat with that of your aqua regia mixture. Okay, you are going to get as a platinum hexachloride. So whatever you are going to get, this is the most simplest form. E form ಇಂದ ನಾವು ಈಸಿಯಾಗಿ ಗೋಲ್ಡ್ ಮತ್ತೆ ಪ್ಲಾಟಿನಮ್ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬಹುದು, ನಾಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿ ಓರ್. ಸೊ ಇದನ್ನು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಲೇಬೇಕು ನಾವು. ಸೊ ದಟ್ ಇಸ್ ಡನ್ ಬೈ ಯುಟಿಲೈಸಿಂಗ್ ಯುವರ್ aqua regia. So 3PtCl6 2 minus plus NO plus water. Okay, nitric oxide ಎರಡು ಕಡೆನೂ ಬರ್ತಾನೆ ಉಂಟು. So in case if you want to balance this is your 3Pt. So here 3PtCl6 2 minus, what about H plus? Here H2 is there, yeah 16H plus. Okay, a very important part, 16H plus you are going to get. So when you are getting 16, here comes your 8 water. What about your nitrogen? How many nitrogen? 1 nitrogen. What about your oxygen? 8 plus 1 9. Here only 3 is present. So 4 and 12 anta bardre ಅವಾಗ ನಾನಿಲ್ಲಿ 4NO3 ಅಂತ ಹಾಕೋಬಹುದು. ಎಸ್ 4NO. So 4 plus 8 and 12. So here 4NO3. Are you able to understand? So basically this is the concept of your aqua regia. Of course stoichiometry you have to understand, you have to get the balance the equation, but the important concept wise I'm going to say, whenever you treat your aqua regia, it has the capacity even to dissolve your noble metals. Okay, ನೀವು ಬೇಕಾದ್ರೆ ಹಿಂದಿನ ಪೇಜಸ್ ಎಲ್ಲ ನೋಡಿ, ಎಲ್ಲಾ ಮೆಟಲ್ಸ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದ್ರೂ ಕೆಲವು ಎಲಿಮೆಂಟ್ಸ್ ನೋಬಲ್ ಮೆಟಲ್ಸ್ ಜೊತೆ ಎಕ್ಸೆಪ್ಷನ್ ತೋರಿಸ್ತಾ ಇತ್ತು. ಬಟ್ ಇಲ್ಲಿ ನಾವೇನ್ ನೋಡ್ತಾ ಇದೀವಿ, ಎಕ್ವಾ ರೀಜಿಯನ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಅದ್ರ 3 ಪಟ್ಟು ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ HCl 1 ಪಟ್ಟು ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ HNO3 ಮಿಕ್ಸ್ ಮಾಡಿ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಅದನ್ನೇ ನಾವು ಮಿಕ್ಸ್ಚರಿಂಗ್ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಎಕ್ವಾ ರೀಜಿಯಾ. ಸೊ ಆ ಎಕ್ವಾ ರೀಜಿಯಾಗೆ ನಿಮ್ಮ ನೋಬಲ್ ಮೆಟಲ್ಸ್ ಕೂಡ ಡಿಸಾಲ್ವ್ ಮಾಡೋ ಸಾಮರ್ಥ್ಯ ಉಂಟು. So coming to the next important property, the last property of your HCl. Basically your HCl has the capacity to decompose the salts of weaker acid. Salts of weaker acid. Weaker acid means we can say as a carbonic acid. Alva carbonic acid is a weak acid. Adurdu salts andre your sodium carbonate, your sodium bicarbonate avdu. So whenever we are going to treat your salts of the weaker acid, you are treated with a HCl. Basically this HCl has the capacity to break this salt and form as that of your NaCl plus H2O with the evolution of your CO2 gas. Similar is the case, we can treat your sodium bicarbonate with that of your HCl. You're going to get as a NaCl plus H2O plus that of your CO2. Even that of your sodium sulfate, Na2SO thrice, plus that of your HCl, you're going to get as an NaCl plus H2O plus that of your SO2 gas. So in all these cases, what you're noticing is, whenever you're going to treat your HCl with that of your salts of the weaker acid, of course your HCl has the capacity to break this salt. Decompose means what? Break these salts, okay, to form the respective sodium chloride, water and the respective evolution of the gas. Carbon idre carbon dioxide gas hogutte, sulfite idre sulfur dioxide gas horge hogta untu. So these were the certain important properties of your hydrochloric HCl. Okay, coming with respect to the uses, of course you can only say that the manufacture of your chlorine ಅಲ್ಲಿ ಯೂಸ್ ಆಗುತ್ತೆ your HCl. NH4Cl ಗೆ ಯೂಸ್ ಆಗುತ್ತೆ, ಅವ ನೋಡಿದ್ವಿ ನಾವು, ಡೆನ್ಸ್ ವೈಟ್ ಫ್ಯೂಮ್ಸ್ ಕೊಡ್ತು. ಈವನ್ ಗ್ಲೂಕೋಸ್ ಪ್ರಿಪರೇಷನ್ ಕೂಡ ಯೂಸ್ ಆಗುತ್ತೆ ಫ್ರಮ್ your corn starch. Similarly, as a laboratory agent also we use many times your HCl. So these are the certain important uses. The last topic of today's session we are going to deal is about your oxoacids of halogen. Oxoacids of halogen. Okay, now let us see through it. What do you mean by this oxoacids of halogen? So in oxoacids of your halogen, we are going to see what are the different oxoacids of halogen are present, okay, and what are their respective structures. So when we were dealing with the chemical properties of your halogen, there we have mentioned, what is that? Only fluorine forms only one oxoacid, that is your HOF. Alva fluorine bari onde oxoacid irodu, that is your HOF. Basically its name is fluoric, FLUROIC. Yes, sorry, fluoric, yeah, FLUORIC. Sorry, FLUORIC 1 acid, or also called as hypofluorous acid. Hypofluorous acid. I just got confused with this formula. Sorry, this spelling. Okay, so fluoric acid antanu helbodu iduna, athwa nimma hypofluorous acid antanu you can call it. Oxidation state of your F is over as a -1. Okay, -1 oxidation state is there. So in the oxoacids of halogen, first of all we'll see what are the different oxoacids you are having. So first we will see with respect to the halic 1 acid. Okay, ಜನರಲ್ ನೇಮ್ ಕೊಟ್ಟಿ ಅದು ರೆಸ್ಪೆಕ್ಟಿವ್ ನೋಡೋಣ. ಸೊ ಎಲ್ಲಿ ನಿಮ್ಮ ಹ್ಯಾಲೋಜನ್ ಗೆ ಒಂದು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇರುತ್ತೆ. ದ ಫಸ್ಟ್ ಪಾರ್ಟ್ ಇಸ್ ಯೋರ್ HOF, ಫ್ಲೂರಿನಲ್ ಬರೋದು ಒಂದು, ಕ್ಲೋರಿನಲ್ ಕೂಡ ಒಂದು ಬರುತ್ತೆ HOCl, BR ಅಲ್ಲಿ ಒಂದು ಬರುತ್ತೆ HOBr and that of your HOI. ಸೊ ಪ್ರತಿ ಒಂದು ಹ್ಯಾಲೋಜನ್ ಆ ರೆಸ್ಪೆಕ್ಟಿವ್ ಹ್ಯಾಲಿಕ್ 1 ಆಸಿಡ್ ಕೊಡ್ತಾನೆ ಉಂಟು. ಇಲ್ಲಿ ನಿಮ್ಮ ಹ್ಯಾಲೋಜನ್ಸ್ ಹತ್ರ ಇರೋದು +1 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್. ಇದು ನಿಮ್ಮ ಹೈಪೋಫ್ಲೂರಸ್ ಆಸಿಡ್, ಹೈಪೋಫ್ಲೂರಸ್ ಆಸಿಡ್. ಅಫ್ ಕೋರ್ಸ್ ಇದು ನಾವು ಯಾವ ತರ ಹೇಳ್ಬೋದು, ಹೈಪೋಕ್ಲೋರಸ್ ಆಸಿಡ್, ಹೈಪೋಬ್ರೋಮಸ್ ಆಸಿಡ್ ಅಲ್ವಾ, ಹೈಪೋಅಯೋಡಸ್ ಆಸಿಡ್, ಹೈಪೋಅಯೋಡಸ್ ಆಸಿಡ್ ಅಲ್ವಾ. ದಿಸ್ ಇಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೆನ್ ಹ್ಯಾಲಿಕ್ 1 ಆಸಿಡ್. ಎಲ್ಲಿ ನಿಮ್ಮ ಹೈಡ್ರೋಜನ್ ಮೇಲೆ 1 oxidation state, -1 oxidation state ಉಂಟು. ಅದೇ ರೀತಿ coming with respect to another oxoacid, that is your halic 3 acid. halic 3 acid ಅಲ್ಲಿ ರಿಮೆಂಬರ್ ಫ್ಲೂರಿನ್ ಹೇಗೂ ಇಲ್ಲ, ಯಾಕಂದ್ರೆ ಅದು ಬರೀ ಒಂದೇ ಆಕ್ಸೋ ಆಸಿಡ್ ಅಂತ ಇದೆ. ಅದೇ ರೀತಿ ನಿಮ್ಮ Br ಮತ್ತೆ I ಕೂಡ ಈ ಒಂದು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗೋದಿಲ್ಲ, +3 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗೋದಿಲ್ಲ. ಸೊ ಓನ್ಲಿ ಒನ್ ವಿಚ್ ಇಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿ ಕ್ಲೋರಿನ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್, ದಟ್ ಇಸ್ ಯೋರ್ HOClO. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ದಟ್ ಆಫ್ ಯೋರ್ ಕ್ಲೋರಸ್ ಆಸಿಡ್. ಸೊ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಕೂಡ ಕೇಳಬಹುದು. ಓಕೆ, halic 3 ಆಸಿಡ್ ಅಲ್ಲಿ ಯಾವ ಒಂದು ಹ್ಯಾಲೋಜನ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ಇಟ್ ಇಸ್ ಓನ್ಲಿ ಯೋರ್ ಕ್ಲೋರಿನ್. Then remaining, of course, except fluorine, ಇನ್ನೆಲ್ಲವೂ ಬರ್ತವೆ. That is your halic 5 acid. halic 5 acid ಅಲ್ಲಿ basically ನಿಮಗೆ HOClO2, HOBrO2, HOiO2. In all these cases you have, which is called as your chloric acid. Okay, see the name, chloric acid, bromic acid, and that of your iodic acid. Coming the next part, that is your halic 7. Okay, halic 7 acid. Okay, illu kuda you will be having as a HOClO3, HOBrO3, and that of your HOiO3. So all the three halogens are existing except that of your fluorine part. So basically their name is perchloric acid, perbromic acid, and periodic acid. Now let us see one by one their structures. Some important structures only we are going to discuss. Okay, so first of all we'll see the structure of your hypochlorous acid. Hypochlorous means which one? Yes, it is your HOCl. Simple structure, H irutte, O irutte, Cl irutte. Okay, simple part. Coming with respect to the chlorous acid, basically ನಾವು ಓವರಾಲ್ ಈಗ ಈ ಒಂದು Cl ದೇ ನೋಡ್ತಾ ಹೋಗಿ, ಹೈಪೋಕ್ಲೋರಸ್ ನೋಡಿದ್ವಿ, ಕ್ಲೋರಸ್ ನೋಡ್ತೀವಿ, ಅದೇ ರೀತಿ ಕ್ಲೋರಿಕ್ ನೋಡ್ತೀವಿ, ಅದೇ ರೀತಿ ಪರ್ಕ್ಲೋರಿಕ್ ನೋಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಇಲ್ಲೇನಾಗಿದೆ, ಯು ಹ್ಯಾವಿಂಗ್ ಒನ್ ಎಕ್ಸ್ಟ್ರಾ ಓ ಅಲ್ವಾ, HOCl ಹಾಗೇನೆ ಇರುತ್ತೆ, HOCl. ನೆಕ್ಸ್ಟ್ ಈ ಓ ಏನಂತೂ ಅದು ಡಬಲ್ ಬಾಂಡ್ ಓ ಅಲ್ಲಿ ಆಗಿದೆ. ಓಕೆ, ಬಿಕಾಸ್ ಈ ಆಕ್ಸಿಜನ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ 2 valency, ಇಲ್ಲೂ ಕೂಡ ಆಕ್ಸಿಜನ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ 2 valencies. Coming with respect to the next part, let me write over here itself. You can write here chloric acid. Okay, chloric acid in a formula ನೋಡಿ, HOClO2 ಅಲ್ವಾ. ಸೊ ಹೇಗೆ ಬರೀಬಹುದು, ಜಸ್ಟ್ ಸಮ್ ಚೇಂಜ್ ಮಾಡ್ತೀನಿ, Cl ಡಬಲ್ ಬಾಂಡ್ O ಅಲ್ವಾ, Cl ಡಬಲ್ ಬಾಂಡ್ O. ಆಸ್ ಯೂಶುವಲ್ ಯು ಆರ್ ರೈಟಿಂಗ್, ಸೊ O ಮತ್ತೆ H ಇರುತ್ತೆ. ಸೊ HOCl ಡಬಲ್ ಬಾಂಡ್, ಎಲ್ಲಿ ಎಕ್ಸ್ಟ್ರಾ ಆಕ್ಸಿಜನ್ ಬರುತ್ತೆ ಅದನ್ನ ಡಬಲ್ ಬಾಂಡ್ O ರೀತಿಲಿ ಬರಿಬೇಕು. ಪರ್ಕ್ಲೋರಿಕಲ್ ಏನಾಗಿದೆ, ಇನ್ನೊಂದು ಆಕ್ಸಿಜನ್ ಬಂದಿದೆ ಅಲ್ವಾ. ನೋಡಿ ಇಲ್ಲಿ HOCl, ಆಮೇಲೆ ಏನ್ ಮಾಡ್ತೀವಿ, ಒಂದು O ಎಕ್ಸ್ಟ್ರಾ ಆಡ್ ಮಾಡ್ತೀವಿ, ಆಮೇಲೆ ಏನ್ ಮಾಡ್ತೀವಿ, ಈ ಓಗೆ ಇನ್ನೊಂದು ಎಕ್ಸ್ಟ್ರಾ ಆಡ್ ಮಾಡ್ತೀವಿ, O2 ಆಯ್ತು, ಅದಕ್ಕೆ ಇನ್ನೊಂದು O ಆಡ್ ಮಾಡಿದ್ರೆ O3 ಆಯ್ತು. ಸೊ ಪರ್ಕ್ಲೋರಿಕ್ ಆಸಿಡ್ ಇನ್ ಹಿಂಗಿರುತ್ತೆ, ಎಸ್, ಒನ್ ಎಕ್ಸ್ಟ್ರಾ ಡಬಲ್ ಬಾಂಡ್ O ಬರಬೇಕು ಅಲ್ವಾ. ಸೊ ಯಾವ ತರ ಬರೆಯೋಣ, Cl ಡಬಲ್ ಬಾಂಡ್ O, and O and a H. ಸೊ ಕ್ಯಾನ್ ಯು ಸಿ, ಏನಿಲ್ಲ, ಫಸ್ಟ್ ನಿಮ್ಗೆ ಈ ಒಂದು ಸ್ಟ್ರಕ್ಚರ್ ಗೊತ್ತಿದ್ರೆ ಇನ್ನೇನ್ ಮಿಕ್ಕಿದ ಆಕ್ಸಿಜನ್ ಉಂಟು ಅದು ಡಬಲ್ ಬಾಂಡ್ O ರೀತಿಲಿ ಬರೀತಾ ಹೋಗ್ಬೇಕು. ಕ್ಲಿಯರ್? ಸೊ ದಿಸ್ ವಾಸ್ ದಿ ಟುಡೇಸ್ ಸೆಷನ್ ವೇರ್ ವಿ ಹ್ಯಾವ್ ಕಮ್ ಟು ನೋ ದಿ ಡಿಫರೆಂಟ್ molecules and the compounds of the chlorine. That was your chlorine as it is, then that of your hydrogen chloride, and that of your oxoacids. Of course, I was planning to do the interhalogen compounds, but this video is becoming too long, so I'm going to do in my next session the interhalogen compounds and that of your group 18 elements.